push that rock here with some math. Let's verify some simple identities relying on our basic identities, okay? So I have here an identity right here. This is identity. Ooh, can we get all? I better zoom in a little. There we go. Okay, zoom out, zoom in. I'll never get those terms correct. I'm too old for that. But anyway, you can all see the screen now. And I have an equality that I propose is an identity. And so my instructions to the student is to verify the identity. That means the student is supposed to assume that this is a true statement all the time, except obviously where secant would be 0. But secant is never 0, so we're safe there. And also maybe because of tangent here, that means, remember, tangent is sine over cos. So if cos is 0, tangent is not defined. So except for where cos is 0, this should always be true. And we want to verify it. Now, the process is to pick one side or the other and deal only with that side, not changing its value. So you have to do algebraic manipulations that can include substitution, multiplying by 1, adding 0, things that don't change the value. So you pick one side, you deal only with it, with the goal of getting to the other side. So in this case, I'm going to pick the right-hand side. So I'm going to say RHS for right-hand side is equal to 2 sec squared x minus 2 tan squared x, take away 1. And my goal is to get to this other side, which is sine squared plus 1 over sec squared. All right, and I want this side to turn into that over there, but I can't change its value. Well, one thing I can do is I can factor out a 2 from these two terms. So from these two terms right here, they both have a 2, I can factor that out. So I'm gonna do that. That gives me sec squared x minus tan squared x inside these parentheses, both being multiplied by 2. So I have not changed the problem any at all, okay? Then this clues me into a Pythagorean. Now, I've kind of jumped the gun here. You have to justify each step. So the first step, this is given to us. But here, all I did was factor. So just put a phrase or word over here to explain what you've done, okay? So I factored out a 2. But now I'm thinking Pythagorean because I see sec squared together with tan squared. So let's write down the Pythagorean identity that we rely on. We know that cos squared plus sine squared is equal to 1, but we also know that if I divide through by cos squared, this becomes 1. Sine squared over cos squared will be tangent squared, and 1 over cos squared is secant squared. So this is one of our Pythagorean identities, and notice what happens. Oh, can we see that? I gotta think about the screen, silly me. So cos squared plus sine squared equals 1. If I divide the cos squared by cos squared, I get 1. Sine squared divided by cos squared is tangent squared, and 1 over cos squared is secant squared. But notice if I subtract the tangent squared over, I have secant squared x take away tangent squared x is the same thing as 1. So using this idea right here, that sec squared minus tangent squared is equal to 1, I can replace this with a 1. So 2 times 1, this is called substitution. I substituted in an identity. So I have 2 minus 1, which is 1. Now what was my explanation here? Well, just simple subtraction. And then, or I guess that was multiplication, going 2 times 1 is 2, and then I subtracted to get 1. So I'll move this down a step, and we'll just call this simplify. Whoops. And maybe the viewer is saying, wait a minute, it looks like you're further away. But am I? We famously know, look right here, cos squared plus sine squared is 1. So I can change this 1 to cos squared plus sine squared. And that's my Pythagorean. So I could write it again like I did there, or I could just give it its name, which is the Pythagorean identity. Okay? And then we know that cos is 1 over secant. And so cos squared is 1 over secant squared. Oh, look back at we have in the wrong order, but addition, the order doesn't matter. So we have 1 over sec squared plus sine squared. So we have the left-hand side. I guess I should put it in the right order. So we'll have sine squared x plus 1 over sec squared x, and that's just commuting, or you could say rearrange. The addition or order of addition doesn't matter, or a plus b is equal to b plus a. You don't have to come up with the exact same wording of your justification that I would come up with. You just have to come up with a justification that makes sense to the reader being me, okay? So there's a lot of things you could have said here, but this is the commutative property of addition, so I'll say commute, where you just change the order. And then this is the left-hand side. And you put your little proof complete symbol. I expect you to have a nice creative one. I'm just using the traditional black box. Now, let's look and see that we have everything we needed for this verification. So for a verification to be good, you need, there we go. You need a vertical line of equal marks. I have that. If you start getting horizontal equal marks, it's not gonna make me happy. It's not gonna be easy for me to grade, easy for me to understand. I need a vertical line of equal marks. For every step, beginning with the first one, I need a justification. Second step, looks like this was a big time justification for that. So third step, and then fourth step, fifth step, sixth step, seventh step, eighth step, and then we're done. And I start with the right-hand side, but so this is still understood to be right-hand side over here equals the left-hand side. That means I'm done. When I start with the right-hand side and I end up with the left-hand side, or vice versa, I'm done. Math made simple, Simpson math.